Okay, so on your test next week, right, you're going to have a calculator portion. You're going to have a non-calculator portion. Yeah.
I don't distract our non-calculator portion with the calculator.
No, that's why it's the non-calculator portion. So you're going to be given, I don't know how we're going to do it. We'll probably give you the calculator part and say you need to turn it in within 20 minutes. If you've worked on it for 20 minutes and you still don't know, you need to turn it in because you're not going to get the other part done. But you're going to have 2 or 3 questions that are without a calculator and 2 that are with, okay? So this is exactly the types of questions that you're going to see. I want to do the with calculator first. Okay, I want us to work on this first, then we're going to put our calculators away and talk about how to deal with the non-calculator portion. Tomorrow we're going to start 4.1. It's not anything to do with this, but it is very algebra based, so you guys will be fine. But let's go ahead and move to the last question. I think I have it labeled, I don't even know what number that is. Looks like a 3 or a 7. But go to this last question. All right, when we look at this question, guys, you should ask yourself every single time you look at a problem that's asking for the zeros and all that stuff, how many answers should I have here? 4. When I algebraically work this out, I'm going to get 4 answers. They may not all be x-intercepts, but I am going to get 4 answers. Let's talk about the end behaviors of this graph. What are the end behaviors of this graph? Before you even graph it, what do the ends look like? The ends are both going same direction or opposite? Why are they going the same? Because it's an even exponent. Since x to the 4th is positive, they're both going in what direction? They're both going up. So your end behavior would be rising right. Sorry. Yes. Rising left and rising right. Always go left to right. Yeah.
When do you add the x to the...
When it's already factored. We'll talk about that. Hi. All right, so what is the y-intercept? Just looking at this, what is the y-intercept? 0, -20. If you have to list that on the line and you write -20, you're going to get points off. We have to write our intercepts as 0, -20, okay? If it's asked for intercepts, you write it as ordered pairs. Make sure you guys are paying attention to stuff like that. So now let's go ahead in our calculator. Throw this in your calculator and tell me what you see. Okay, so in our calculators, we have x to the 4th minus 5x cubed plus 3x squared plus 16x minus 20. Make sure you check to make sure you put everything in correctly. And when you hit graph, do you notice that your graph, both of the ends are up, right? What does it look like happens on this graph? It looks like it bounces off. Okay, good. So let's talk about this. Let's find all of the intercepts. I know we only work on finding one and then we do algebra, but I want to find all of them, the decimal equivalents. So let's go to the far left. Second trace 2. Let's go to the far left. Let's see what that intercept is. What do you guys get? X equals -1.79128. Oh, okay. What's the fractional equivalent to that? Anybody know? No. So that's probably a radical answer, right? So let's move over to the other one. Let's see if we can figure out what the other one is. What'd you guys get for the other one? 1.999999997. For some reason, I don't know why it doesn't give us x equals 2, but this is x equals 2. You got 2.00? Okay. Some calculators, for whatever reason today, some are giving 2 and some are giving the 1.9999997. On the test, you will get one that is either 0.33, something that you can convert to a fraction, or if it is a whole number, it'll be the whole number. It won't be one you have to round. For this one, it is x equals 2. And we're going to prove it algebraically here in a second. But what do you guys know about x equals 2 here? There's 2 of them. Why is there 2 of them? Because it bounces off. Now, I want to talk to you guys. There was a couple of you who had a question yesterday on a homework question. It was a great question. Hold on 1 second. There was a problem, and it looked like there was multiplicity at 1/2. All right, so when I algebraically worked it out to show why there was or wasn't, I did 1/2 synthetically divided, and I got 0 as a remainder. So then I did 1/2 again, and 0 was not the remainder. So I was like, wait a second, what's going on here? So when I look back at it, you had to zoom in really, really, really close, but it was actually 1/2 and 1/3. But that's a good way to say, if you think there's multiplicity, I mean, you have to do the synthetic division. So if you do the synthetic division twice and it's not a remainder of 0, then you know, oh wait, it's actually not multiplicity. But when you work the problem out, the one I'm talking about, you got 1/2 and then the last, the quadratic factored into the 1/3 into the 3/2. But I'm just saying, algebraically, you can always prove if what you're seeing on the calculator is exact. Because again, you could zoom in, you know, like super close, that sort of a thing. But let's go ahead for practice. Let's find the one to the far right. Let's go over to the far right. Second, trace 2. And let's find what the decimal equivalent is to that one on the far right. What'd you guys get? X equals 2.79, 2.7912. Okay. So on your test for the calculator portion, probably, I'd say 85, 90% is going to be a decimal that you convert to a fraction, like we did yesterday with the 0.33, 1.333, the 0.2, something like that. Sometimes it works out to a whole number, which is great, makes life easier. But in this case, guys, we've identified all 4 of our zeros. So what do I do with my x equals 2 that I have twice? How do I figure out what this is and what this is exact? Because your calculator won't just convert that to a radical. So what do I do? Synthetic division. So let's use synthetic division. I have 1, -5, 3, 16, and -20. So when we synthetically divide, 1 times 2, 2, -3, -6, -3, -6, 10, 20, 0. So yes, this actually is x equals 2, correct? So I proved that this one is a 0. So what do I do again? Synthetic division again. So when I do this again, I should get 0, which will prove the multiplicity. So I'll bring this down. I get 2, -1, -2, -5, -10, 0. Yes? Okay, so we proved that there is actually multiplicity at x equals 2. So what do I do with this leftover? This is x squared minus x minus 5 equals 0. Check to see if it factors. Does it? Yes or no? So we have to use the quadratic formula. So I have -1 plus or minus the square root of -1 squared minus 4 times 1 times 5 all over 2 times 1. So as we simplify, 1 plus or minus, this should be a -5. So 1 plus 20 over 2. So x equals 1 plus or minus. So I have 1 plus or minus the square root of 21 over 2. All right, that makes perfect sense. That's fine. What can I do, since I have my calculator in my hand, to check to make sure that I didn't make any mistakes, that is the actual answer? I can say 1, do this in your calculator, guys, practice. 1 minus the square root of 21. Hit enter, then hit divided by 2. And what do you get? You get the first one, right? Then I can say, hang on, Luke, then I have 1 plus second square root 21, enter, divided by 2. And I get the 2.79. So when you have your calculator, you can go back and check your radical answers to make sure that they actually match. You didn't make a mistake or anything in your work. Hold on one second, Luke.
So are we going to have to put our radical answers? Or can we...
Radical answers, no decimals. Yeah.
So we're supposed to put the quadratic formula, just simplify it, that we can plug in, not the decimal ones?
Correct. This is the answer that you need. This, if you write this, it's just going to be marked wrong.
Okay.
Valerie.
So every time it gives us a decimal like that, we have to check it?
You don't have to. You don't have to. I'm just showing you that when you work,
Test, like,
you don't have to. No, if you write just this decimal, it's wrong. You have to show the synthetic division and then find the exact answer. You have to show this, not just that. I just find that and show you that that is equivalent to the radical.
Okay, and then you said to put the answer we got for quadratic equation in the calculator. What does this number have to do?
This is this. Your calculator, you say 1 plus the square root of 21 divided by 2, you get 2.79 whatever. If you say 1 minus the square root of 21 divided by 2, you get negative 1.79. So I'm just showing you, you found, your calculator told you when you did second trace 0, you found the negative 1.79, you found the 2 point. I'm just showing you that that is the exact answer for that decimal equivalent. Aiden. All right, so if you are asked, which you will be, for some additional points. If you have your calculator in your hand, guys, how do you find the additional points? For the additional points, you hit second graph. And what comes up? A table of values. So you don't have to do anything. You just have to write them down. And then if you are asked to graph, which you will be, you need to make sure that you have your x-intercepts in the right spot. You have your y-intercept in the right spot. You have your additional points in the right spot. You have your calculator in front of you to guide you at what it looks like, but you should have a point in between -2 and -1. You should have a point at 2. You should have a point in between 2 and 3. Your graph should bounce off 2. It should go through negative 1.7 whatever and positive 2.7 whatever. Yes, ma'am.
Can the y-intercept count as an additional point? Because it's not.
It depends. If they ask you for the y-intercept specifically, then no. Like if there's a line for y-intercept and then there's additional points, don't list it twice. Yeah.
Why did we do synthetic division twice? Oh, synthetic.
Because you had two times. You have multiplicity of 2 because it didn't go through, it bounced off. So you have 2, actually, it's a factor twice. All right, calculators away. I want to do the rest of it without a calculator. If you guys practice your homework with and without, I understand to get extra practice. But again, you need to know how to do all of the non-calculator without your calculator. So put it away. All right, the difference between question 1, which you'll have something like this, and the questions 2 and 3 are question 1 is already factored for you. This threw some of you for a loop, but this is actually much easier to deal with. How many zeros, what is this? X to the what power? If you multiplied all this together, what is this equation? X to the what? X to the 4th. Some of you are like, okay, how did people know that? Look, how many of this parenthesis do you have? 2. How many of this one do you have? 1. And how many of this one? 1. So it's a total of 4. So you could tell the end behavior right now for this graph. What's the end behavior? Is this, they're both, it's even, so both going in the same direction. Do you see any negatives out in front of the parentheses? No. So what's your end behavior? Rising on the left and rising on the right. It's important to know the end behavior so you get an idea of what your graph is going to look like. Right away, you guys in your mind, you're like, oh, both of the arrows are going up. Anthony, if you want to move, you can. Okay. All right, so we can go ahead and solve and find our x-intercepts. I have x equals what number here? 1, okay. How many times do I have x equals 1? 2 times. So what does that tell me my graph is going to do at the x-axis? It's going to bounce off. Good. See, so much information just by knowing what multiplicity and stuff means. So here I have x equals what? -2. How many times? 1 time. So what's it going to do at the x-axis? Cross through. Good. And here I have x equals 3. Okay. How many times? 1 time. So it's going to do what? Go through. Perfect. All right. So I know what the ends of my graph look like. I know what each intercept is. I know what the graph is going to do at each intercept. How do I find the y-intercept for a question like this? You plug in 0 for the x's. So I have 0 minus 1 squared times 0 plus 2 times 0 minus 3. Perfect. What's 0 minus 1? -1 and -1 squared is? 1. 0 plus 2 is 2. 0 minus 3 is -3. So what's your y-intercept?
-6.
Perfect. And I'm going to write that as 0 comma, negative 6. So let's go ahead and sketch a little graph here for a second. Let's just talk. So look, I have end behaviors are both up. Where am I at? Negative 2, 1, right? And 3. I have points there. I know my intercept is down here. 1, 2, 3, 4, 5, 6. All right, so if you're asked for additional points in a question like this, how would we find additional points? You're going to plug in a number in between. Look, you want to plug in a number here in between negative 2 and 0. What's an easy thing to plug in? Negative 1, okay? If I plug in a number here between 1 and 3, what's something easy to plug in? 2. So if they ask you for 2 additional points, plug in negative 1 and plug in 2 and just see what those points are. You're going to be asked for additional points so you know how high and how low to go. I'll give an example of one. Let's plug in x equals 2. Yep.
Can you use the y-intercept as an additional point?
Okay, if it asks for just additional points, list whatever you want. But if the question asks for what's the x-intercept, what's the y-intercept, then the y-intercept is not an additional point. So just read the directions. All right, so I'm going to plug in 2. So I have 2 minus 1 squared, 2 plus 2, and 2 minus 3. So 2 minus 1 is 1. 1 squared is 1. 2 plus 2 is 4. 2 minus 3 is negative 1. So what is one of my additional points? Plugged in 2, got out what? What's 1 times 4 times negative 1? Negative 4, okay? So I'm going to put that on my graph. 2, 1, 2, 3, so about there. So you guys have enough information here to go ahead and draw a guy. I go through negative 2, I bounce at negative 1, I come back through that additional point, and my graph looks like that. Questions? I'll be specific. All right, let's do the next 2, and then we're done. Excuse me, then we're done. This one is not factored yet, but I do know a lot of stuff about it just by looking at it. What is the end behavior? What is my graph going to look like at the ends?
It falls on the left.
It falls on the left, and it rises on the right. Some of you are still sitting here being like, how do these people know that? Okay, we look at the highest exponent. The highest exponent is an odd number, so we think opposite. Since the leading coefficient, the number in front of the highest exponent, is a positive, we think of like the ends of a positive line. So we say this is falling on the left-hand side and rising on the right. So it gives you an idea. So now when we go to algebraically solve this, how many answers are we going to get? 3. Are all 3 of them necessarily going to be on the graph? No, but they could be. So what do I do? I can't group this, so what do? You got to look at the last, right? Possible zeros is last over first. We like that the first leading coefficient's a 1. So I just have to say, okay, I have plus minus 1, 2, 7, and 14, right? Now, guys, the beauty with this, I want you to pay attention so you don't have to think about how do I do extra work. When you are using synthetic division, so let's do 1, right? Let's see if 1 works. 1, negative 5, negative 114. 1 times 1 is 1, negative 4, negative 4, negative 5, negative 5, 9. Is 1 an x-intercept for this problem? No, because I didn't get 0 as a remainder. But what did you uncover here, guys? You uncovered an additional point that is on this graph. When you use synthetic division, in reality, you're plugging 1 in for x to see what your y value is. So you don't have to go back at the end and then be like, okay, well, I got to find additional points, so now I got to plug stuff in. Anytime you do synthetic division and it doesn't come out with a remainder of 0, what you have discovered is a point that is on the graph. So there's one additional point. We don't even have to worry about that. I could write it on the line if it asks for it. So let's try negative 1. 1, negative 5, negative 1, 14. Negative 1. Negative 6, 6, 5, negative 5, 9. Is that a factor? Is this an x-intercept? No. But did I find another additional point that's on the graph? Yep. That's helpful. So let's try 2. Hopefully 2 works. 1, -5, -1, 14. -3, -6, -6. Ooh, what do we find out here? One of my intercepts is x equals what? 2. Perfect. So just by doing synthetic division 3 times, we have found one of our x-intercepts and 2 additional points. Now, we've done this 50,000 times. What do I do with what's left over here? How do I write that? X squared, perfect. Minus 3x minus 7 equals 0. We cross our fingers and hope and pray that it factors. Does it? No. So, quadratic formula. Negative b, so positive 3 plus minus the square root of -3 squared minus 4 times 1 times -7 all over 2 times 1. So 3 plus or minus, what's -3 squared? 9 plus 28 over 2. So your other 2 intercepts are at 3 plus or minus the square root of 37 over 2. All right. Is that a real number? Yes. Is it beautiful? You know exactly where it is? No. So here's where you guys are going to struggle. Yes, ma'am.
Why didn't we do the quadratic formula if it's like an exact number?
Okay, yes, you got 2, x equals 2, but there's still 2 solutions that you have to find. And they're hidden in there. So you either factor that or you have to use the quadratic formula.
Oh, and what if I just keep doing synthetic formula? Will it eventually give me a number?
No, because, I mean, those are the 2 answers. So to get synthetic division, you're not going to get that as an answer. Like, you wouldn't synthetically divide by that.
Yeah.
Right? So as soon as you get to a quadratic, just do the quadratic formula. Yes, ma'am.
How do you know like when to stop it? Just when it's like x squared?
Yeah, as soon as you get to x squared, just either try to factor it or quadratic formula. It's the easiest way to do it. All right, so this is going to be the hard part for you guys. You know where x equals 2 is on a graph, but you're not exactly sure where this is. This is where we have to think a little bit, guys. What is the square root of 37 close to? 6, right? The square root of 6. So think about this. This is really close to 3 minus 6 over 2 and 3 plus 6 over 2. Because you need to approximate correctly for your graph. So what is 3 minus 6? Negative. So this is close to -1.5. And this one is close to 9/2, right? You guys agree? Okay, so if you're going to graph this, go ahead and tell me. We didn't identify this. We can now. What's the y-intercept? 14. So 0, 14. So we have a whole bunch of information that we can put on a graph. $14 is going to be way up here, right? So think about, I have a point here at 2. And where are my other 2 points? My x-intercepts? -3/2, so ish. So it's going to be here. And then where's 9/2? A little bit bigger than what? 4, okay. So say here. And then those additional points we found. We're at -1,9 and +1,9. So like about here-ish. Just to give you an idea of what your graph looks like. You said your end behaviors were falling on the left and rising on the right. What happens at the x-axis for each one of our intercepts? Does it bounce or go through? Does it bounce or go through? It goes through because there's no multiplicity. So watch, just go through here, back through here, and here. Yes?
So
Janelle's question was, since you found these 2 additional points here, do you need to find something in between here to see how low it goes? That's probably a good idea if you want to do that. Figure out one high one and one low one. So would you have to think about that, Janelle? What number would you use? Okay, so say 3. Would you plug 3 in or do synthetic division? Or does it matter? Doesn't matter. So if you wanted to find the point for 3, let's just do it real quick. So 1, -5, -1, and 14. So this is -2, right? -6, -7, -21. So this would be -7. So you'd have a point at 3, -7. So like here. But you don't have to go back and plug it into the equation. In theory, that's what you're doing by the synthetic division. You're just plugging back in. But that's a good idea. In between each intercept so you know how high and how low. All right, let's look at the last one. Again, same thing, guys. What's our end behaviors? Same as the last one. Same thing. It's falling on the left, rising on the right, okay? How many answers should I have here? 3. Are they all going to be on the x-intercept? Maybe, maybe not. Let's see. So I'm going to use the last over the first. So plus minus 1, 2, 4, 8, and 16, okay? So let's try 1. 1, -1, 6, -16. Bring down your 1. 1 times 1 is 1. This is 0, 0, 6, 6, -10. Is this an x-intercept? No, but did you find an additional point? 1, -10. Perfect. Okay, let's try -1. 1, -1, 6, -16. 1 times -1 is -1. -2, 2, 8, -24. Is that an x-intercept? No. Is that an additional point? Perfect. So let's go with 2. 1, -1, 6, -16. 2, 1, 2, 8. What'd you find out? 2 is an intercept. X equals 2. That's one of our intercepts. Perfect. So I have 2 additional points I found, and I found one of my intercepts. So what do I do with what's left over here? X squared plus x plus 8 equals 0. Can I factor that? No. So I'm going to use the quadratic formula. -b, so -1, plus or minus the square root of 1 squared minus 4 times 1 times 8, all over 2 times 1. So -1 plus minus 1 minus 32 over 2. Guys, what do you know about these two intercepts or do x values? They're imaginary. So it's -1 plus or minus I square root of 31 over 2. So you found all 3 answers, but only one of them are on a graph, correct? So if you are going to graph this, you would have your point here at 2. You know your end behaviors. You know some additional points. 1, -10, so maybe here-ish. -1, -24, maybe here-ish. So when you connect your dots to make your little graph here, is this going to form a straight line? Yes or no? No, this is a cubic function. It's x cubed, so it's not a line. So when you graph this, and you're just going to give a little graph, don't make a straight line. Make it curved a teeny bit. So you understand, hey, you show me, you understand, oh, it's not an actual line. Now, if they ask me for another additional point, say they asked you for 3. You found 2 of them already. How could you find another one? Just synthetic division with any of the factors, and you'll find a point. It's no big deal. Synthetic division will give you all of the additional points. Okay? All right, so practice tonight. You guys have more practice with your calculator, without your calculator. I'm not so much looking for all of your work. People are like, what exactly do I have to show you? You guys know what you have to show me. So if you turn your homework in and all you have is answers written down, I'm just going to give you a 50 if you turn it in on time. But if it shows like you put in some work, you were working on synthetic division. But remember, guys, homework is a very small percentage of your overall grade. Your tests and your quizzes make up a majority of your grade. So you really need to know how to do these things for next Wednesday. It's really important. Okay? All right, we're starting 4.1 tomorrow.